Okay, so tell me if you have any questions with these. When you're looking for an initial investment, that's your P. Your rate, don't forget to put it to a decimal. Continuously, there's your PERT. And since it's money, two decimal places. Some of these you just have to plug in. Some of them you have to do graphically. Okay, to determine when, the when part, when we're looking for time, put this in your calculator. Y1, Y2. You're giving me a basic graph. Your money is growing, and it doesn't start at the zero because you have an initial investment. So it doesn't start at the zero, it grows, and all of them pretty much follow the same setup. This would come from here, otherwise, but we obviously changed your intercept because we started at 2300. So intercept and find your years. Make sure you give me 3 decimal points when it asks for any time frames. Everybody can do this? You're going to change your windows. This is a good indication of your Y max. Keep your both mins at 0. Your X max, if you want to, look in your table. You can go to your table before you even set your X and your Y's. Or you can just kind of guesstimate. Usually these don't go more than 20, 25 years. So you can kind of like guesstimate it a little bit. Okay, another when does this happen? Put it in your calc. Everybody comfortable? Yeah. Okay. When it doubles, we talked about doubling. You could set any amount you want. 100 to 200, 1,000 to 2,000. When we reduce it down, it's a 1 to 2. So 1 to 2 puts you in a nice little screen. If you want to do 1 to 2, whatever it is you want to do, that's fine with me. As long as you're doubling. I think it's easier to see the 1 and the 2, doubling, tripling, 1 and 3. We usually don't ask more than tripling. Okay. Here's another one. Determine the annual interest rate. This time you're looking for the rate. Now your rates are usually 8%, 6%, and so forth. If you flip this to a decimal, it is a lot less than 1. So if that's the value of X that you're looking for, on your X-axis, if you go by ones, your rate's going to be real close to this line. Because this is going to represent your X this time. Now your calculator sees this. Your graph may look like this. If you did an intercept, it still finds it. If you want to make it easier on the eyes, go from 0 to 1. And then you'll see slight movement here. And then it'll cross. Olivia, did you have a question?
I put for my final answer 0.08.
0.008, just give me 3 decimal places. 0.08, great. The reason we do 3 is also because if we move our decimal point, it doesn't just cut off at 0.08. It has a little bit. We know there's something else there.
So the decimal or the percent is fine?
Yes. And 3 places is fine. And it still will find that there. Even though you can't see it, it's there. There's another one, determine the rate. Again, the rate is the small one. If your X is from 0 to 1, you'll see it better. Change your window. There's your max on your Y. So it's kind of nice that we know our max is right. Here's another one, determine how much time it takes to double. You're compounding quarterly. Y1, Y2. Everybody good with these? Yeah, these are the easy, nice ones. And then this one I just gave you after 5 years, the standard one, don't do Y equals. I like to throw these in because after we do a lot of the Y equals, everybody starts throwing these into their Y equals. You'll get a straight line. So make sure you do this in your regular part of your calculator and you just give me an answer. And again, we can see growth based on our compounding. Okay. And a continuously. Good? Just right here?
Yeah.
Uh-huh. Again, be careful in your calculators. If you're using the 83, when you put this in, don't forget this exponent only belongs to the 8. Now what happens when you put this in your calculator and it goes like this, you have to put this in parentheses. You have to put this in parentheses, otherwise it'll raise it to this, and then it'll multiply the whole answer by 5. So watch your parentheses. If you're using the 84s, it automatically moves you up into the exponent area.
Ashley, what did you get for annually? I'm sorry.
That's okay. We'll go back.
About 0.11.
Yeah, I got that too.
Okay, before we talk applications, let's talk basic setup of your exponential growth and decay. Your interest formulas follow the same setup as well. A is your initial value. If you remember this, this will help you through all of your exponential growth and decay. This is some kind of rate in here. Sometimes we have an increase, like we do in your interest problems. Sometimes we have a decrease, 1 minus, and it retains what's left over. Sometimes we just say double, sometimes we say triple. That'll go in the B. X is the time factor. Sometimes time is in days, months, years, minutes, seconds. And we have to make sure that what they're asking us is in the same type of minutes, seconds, days, whatever. Sometimes we have a cycle, so it's like a half-life. A half-life says every 5 years, every 10 years, my element cuts down to half. That's where we take care of it in here. We put the time over its cycle. So this is kind of like your basic format for your growth and decay. They all work off of this guy, y equals ab to the x. If you remember that, we should be good. Now, this guy says the number of bacteria triples every 4 days. Initially, there are 1,000 units present of bacteria. How many are present in 4 days, in 8 days, in 12 days, in 1 day? So you're going to start like this. Are we growing or are we decaying? We're growing. So we should see that our things are growing. What is your initial value? What's your rate of growth? Triples. So how do I represent triples? 3. My time period. Is it just every day? X being every day? No, it's every 4 days. So here is my equation. Now, sometimes you can eyeball these to see where this is going. If I made a chart, like the one down here, I just have to move it down to that one. At the 0, I start at 1,000. Okay, at 0, and when I first begin, I'm 1,000. After 4 days, where am I at? 3,000. So I can kind of see a pattern. When I write my equation and I do this in my calculator, if my table doesn't look like what I anticipated, maybe I forgot to do my cycle, maybe I forgot something else. So this is a good way to start. You're growing. Exponential growth, again, puts you into quadrant 1. You're at 1,000, you're growing. And exponential growth goes up. So you can plug these into your equation. You can plug them in to your y equals. It's probably easiest once we do this, plug them into your y equals and take all those answers right off of your table. I'm going to take this block. All right? We okay with that? You're tripling. This would be every day. This would be every 4 days. And I anticipated my 4 being at 3,000. Right? You can absolutely plug in your days right here. without graphing it, or put this in your Y1 and go right to your table and see your growth. If you have trouble setting your X and your Y's, your X's we're asking you for here. So you can kind of get the maximum days. The Y's, go look at your table for those X's. See where your maximum Y is, and that'll help you graph it. These all kind of follow the same pattern. Here's a population decrease. That means, what will my population be next year? It will be less than what I have this year. And when we do a decrease, we subtract our rates. So when you start like this is your initial value. What is your initial population? 100,000. I'm decreasing. So in my rate, I should have 1 minus my rate. And I'm looking at this every year. This should be in years. Time in years. So this is a good way to start it. When you put your rate in, so this rate is 2.5%. How do I write that as a decimal? 0.025. You're still going to get the same path. You're going to get exponential growth and decay. They work the same way, but now is coming down. My population started high and is coming down. The setup is the same. What you're getting here is what you retain after each year. So each year, if you do this subtraction, I'm retaining 0.975 of whatever the population was the year before that. So I'm retaining a little bit of it each time. And if I was increasing my population, I would just change this to a plus. This looks a lot like your compounding, doesn't it? Don't get confused when we do this with compounding. We don't compound population decrease and increase. We only compound interest. So that's usually a little bit of a thing when kids start doing this, because it looks very similar to where you compound with the P, 1 plus the R. So that it's almost real similar to this guy. If this was 1 and it's very similar, but we don't compound these. We just do a basic, increase, decrease. You feeling that?
Where does 0.975 come from?
The 1 minus 0.025. You don't have to do it. You can put it in your calculator, 1 minus that. But I wanted to show you what the decrease does. The decrease says, don't multiply this by 1 because it would never change. Don't multiply this by 1.02 because it would increase. Multiply it by 1 minus the 0.0275, or whatever it happens to be, so that I decrease it each year. And this is what's retained in your population each year. So you're kind of looking at a decrease, and do it on your calculator, and intersect. What am I going to put in Y2? 95,000. I want to know, when is it going to decrease to 95,000? Remember back in Algebra 1, you actually did this type. But what you did in Algebra 1 is you said, okay, let me just take times it by 0.025, subtract it, keep going. Multiply that by 0.025, subtract it, keep going. That's what we did in Algebra 1. We watched you, we helped you find a pattern, and we kept decreasing until we hit the value that they wanted. Now we're just developing our own formulas for these. Okay, so everybody okay with this? You tell me. 2 point, no, 2 point what? 036? Okay, 2.036. And what do I say this is? Years. Shh, guys, I want to know when this will be. Sometimes they ask, if this is 2014, when will my population reach 95,000? If this is the year 1999, When will my population reach 95,000? In that case, what would you have to do? You'd have to add these years to what date you're at. You have to be careful. Sometimes they say, in what year? Sometimes they start your year at January 1st. So you kind of have to watch what they're asking. 2.6, I got .026.
I got he's grabbing.
Ow.
Graph this. Put this in your calculator,
Oh,
guys.
I know what I did, because I only rounded to the second decimal place first.
First.
And I got 03.
Yeah.
Sorry. That was on me.
Put this in your calculator. Guys, I need everybody's attention. I got it. 1 minus 0.025. Okay, and I want this to hook up to 95,000. Obviously, my Y, I know my X-mins, I know my Y-mins. They're zeros. And my X-max, what's my Y-max going to be? 100,000. That's what I'm starting at. Make it a little bit higher if you wanted to. You should still be in your intersect should still be good enough, but make it a little higher if you feel like it. Try it. The only thing I have to worry about right here is my X-max. I could go to my table and find my X-max, or I could just guesstimate. It's not going to take that long. I have a slow decrease. I'm only 2%, a little bit more than 2% a year, and I do an intersect.
I just made the Y max a little bigger so it wasn't all the way up the
Yeah,
top.
that's what I just said. You can make it a little bigger because you're kind of close when you intersect.
Yeah,
As
when
long
I
as you
did-
can make the intersect, you're fine. Well, it usually happens too. Sometimes down here, you get a little too close to where they write over, so then you want to either
Yeah,
make it
that's what I
further
did
up.
on the top too.
If it is on the top, yeah, then make it come down.
Yeah.
Yeah. Just play with it a little bit. Okay. Now here's a familiar one. This is a half-life. You guys did this in chemistry. Your half-lives. You start with same thing. This I got from one of the science teachers. Basically the same as ours. It's basically the same as ours. A sub 0, this means initial. Over time. Now remember, this has a cycle. A half-life doesn't happen every day, every month, every minute, every year. It happens every so many years. So many days. So your half-life is 12 days. You start with your basic formula. What's your initial amount? Nah, we don't know. So what should we make it?
And
We'll leave it as A for now. What's the amount we want to end up with? 4. So is A going to be greater than 4 or less than 4? Greater than 4. This is a half-life, so therefore this is decreasing, right? We're in decreasing mode. What's my rate? 1/2. And my time would be T. It would be my time. But what do I have to do here?
over 12.
Over at every 12 days. There's my cycle. My time is decreasing every 12 days. So what are they asking us now? They're asking us to find our initial value. So our initial value when? After how many days? 10. Where do I put the 10? T. Okay. Can we solve this? You can put it in your y1, y2, and intersect, or you can solve this without your calculator because your variable is not in your exponent. And remember, this exponent only belongs to this guy. Yes. Yeah, I already put it in the folder. Sorry. I put it in the folder already. If it's easier, solve it without using your y1, y2. So would we come up for A? Right. Good. And that makes sense, doesn't it? And we're going to label this grams because we started with this amount, and every 12 days we're decreasing. Okay, we're half-lifing. So we haven't exactly did half of this yet, right? Our age should not be greater than 8, right? It can't be 8 yet because we didn't reach 12 days. So is that within what we estimated it to be? Yeah. Wouldn't that make sense? Every 12 days, I should take a half-life. I'm not asking, we didn't get to 12 yet. So that means this could not have been doubled yet.
How do you sponsor?
Say that again?
I mean, you said, use the boxes for half-life.
I don't know how to do that.
What chemistry teacher? Which chemistry teacher? Oh, you're not.